Hello and welcome once again. In the previous video, I went over this schematic about ignition switches. I'd like to thank the viewer, as I mentioned before. I'd like to thank him for his observation. In my effort of trying to explain this, I did not go over this part of the schematic, which he pointed out to me. It was a very good observation on his part. I forgot his name. Anyway, thank you for that. And in that, my second effort, I will go over it to make it clearer. So I like viewers when they look at schematics and they ask me questions like that. I really appreciate things like that. They pick up on things, on the schematics and things like that. I mean, that's a great inspiration for me to make such a difficult channel, an educational channel. So again, just to recap what we went over, I think we pretty much went over most of it. As you know, there was a wire over here, a very thick wire over here going to the starter motor itself. That's that thick wire that you see that carries a 200 amps or 300 amps. This one over here, the red one over here, the red one over here goes to the fuse panel, that thick one over here also. So this one goes over here. I wrote the voltages associated with each point over here, before the fuse and after the fuse, before the fuse, after the fuse, before the ignition switch, after the ignition switch, before each component, so you can see how much the voltage measurements should be. So 3 wires. Main one, the main feed one, going to the fuse panel, going to the starter motor, and one coming from the alternator to replenish the battery, going to the positive of it. So red one, another red one over here, another red one, 3 reds. Anyway, so basically what do we need? I think we went over these before. We need first current to go through this. How do you know the ignition switch is good? Well, you follow the current. Okay, there's 2 paths for it to go. It cannot go through this path unless he activates this one. So first you activate this one, current flows. Remember, voltage does not flow. And you're going to see an example of what I'm talking about. You're going to see a very good example of what I'm talking about over here. First of all, current flows in this path. You have to be in the start position over here. Current flows here through another fuse. Through this, remember we spoke about this. We spoke about the park neutral safety switch. You have to be in the park or neutral. As you can see over here, that the connections are only to neutral or park. There's no connection to reverse, no connection to drive, no connection to second gear or first gear. So in the start position over here, current flows through this coil to magnetize it. And now there's 2 paths for it. This is actually for a Ford. So for the Ford, they have Crown Victorias. They have all of them are pretty much similar. Now, there is a police package for one, the Crown Victorias. There's quite a few Fords that have the same thing. If you're dealing with a regular physical ground, all it is a ground, a G109, a black wire. You'll go down this path. You have 2 paths to go. One is for the computer. If you have this type of module, make and model of a car, and one is for the other one, for this one. So if you have a police package, you go this way. If you don't have a police package, you're going to go this way, and the computer is going to control you. Let's take the first path. This path over here to G109 is a straight physical wire. So let's go over here, and it turns it out. Now, going through the voltages. 12 volts here, 12 volts here. First, let's go this path. 12 volts over here, and now 12 volts here. Why 12 volts here? Why? Why not less than that? Why not 10 volts? Because there's just a switch There's no voltage drop across a switch. Now we go over here to the dark green wire. Same thing. 12 here, 12 here. Same thing across this switch. 12 here, 12 here. Over here, at the starter relay, 12. Over here, this is ground, remember? Black wire or gray red stripe. 0 volts here. Why? Because this is ground. So where is the whole 12 volt dropped across? This coil, this relay. That's fine and dandy. Now, thank you for that. Again, thank you for the point for telling me. What if the computer gives it a ground? Now things get a little more complicated. If the computer gives you a ground, then the computer will activate this coil. If the computer activates this coil, now things are different. So the computer will give you a ground. So current will flow here, 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 and to the ground of the computer, wherever that is, to the PCM actually, in the computer board. Fine. Once that happens, current now flows in this way. Remember, there were 2 paths. 12 volts here, 12 volts at the fuse, 12 volts here, and then 12 volts here to the windings, the pulling windings and the holding windings that I made a video about one time. So you can see that video about start if you want to see that. But anyway, so 12 volts here, 12 volts here. Now, why did I just mention, I said I follow current and not voltage, even though I'm giving you voltage measurements. Let's say the computer, we have a problem with the computer. Computer never gave you the ground. If the computer did not give you the ground, what's not going to toggle? Your first response is this one. He's not going to toggle. Meaning, what I mean by toggle, that means 30 is not going to be connected to 87. That means the starter motor will not be activated. In order for the starter motor to activate, this has to go first. Then you get that 200, 300 amps, boom, to start up the pinion gear, to mesh with the ring gear, and to turn of the flywheel to turn the crankshaft. If the relay doesn't do his job, he cannot send 200, 300 amps to do that to the starter motor. Now, I just made a statement. This will not toggle. Why? Because he's not doing his job over here. Why is he not doing his job? Because you know why? The computer did not give it a ground. This does not have a complete path for current to flow. It needs a complete path from positive back to negative to ground. If you do not have, let's say this is open. Let's say this one over here. This is pin 2 of this module, of this computer board. Let's say pin 2 is open or there's no connection. What's going to happen to the current? Current cannot flow. It needs a complete path like this one, a physical ground, but it doesn't have it. This wire is broken. Now, going back to the statement that I made, I'm trying to stress the point. No current can flow now. If current can't flow, he cannot be activated. Starter motor cannot be activated. What's going to be with the voltages? Now, this is the tricky part. 12 volts here, 12 volts over here. How much do I have over here when I put in the start position? Let's say I have a starter problem. You tell your friend, hey, can you get in the car, start the switch for me? Starts the switch. I put my meter over here on the other side of the switch. How much should I get? Remember, computer did not give it a ground. How much should I get over here? 12 volts. Why? Because I'm connected to the battery. See how I'm connected to the battery? When you put in the start position, how much should I get over here? 12 volts over here. How much should I get over here? 12 volts over here. Remember, no ground, the computer. How much over here? 0 volts? No. There's no current flowing, so there's no voltage drop across this. If there's no voltage drop across this, and this is 12 volts, we're talking about how much am I going to have here? 12 volts. A floating. It's going to be floating, they call it. How do I have 12 volts if I have no current flowing? This is exactly my point. When you teach this, You cannot teach. You have power here, power, as you see in so many videos. You have power here, power here. Just because you have voltage does not mean you have current. Right? If you go to your outlet, your house outlet, you measure 120 volts. You have nothing connected to it in the outlet. Do you have current flowing? No. But what do you have? You have voltage coming out of your outlet, 120 volts RMS at 60 hertz. Very important to have 60 hertz. If you have 57 hertz, call the electric company. So anyway, you still have voltage, but you have no current. This is the main point I want to stress to you. If you go over here, if you don't look at the schematic or pull out a schematic, you're going to misdiagnose. You're going to go over here and say 12 volts here, 12 volts over here, 12 volts over here, 12 volts. Oh, okay, whatever. No, you have to look at the schematic. You do not have current flowing. You will have the voltage drop, sure, you'll have the voltage drop. But when instead of having a zero connected to ground, you'll be floating. You'll be at 12 volts, depending what's in the computer. In order for me to understand that this is working, I have to have a voltage drop across it. And if this is 0 volts, this is 12 volts, I lose 12 volts across this whole thing. If this is at 12 volts or whatever, 11 volts, whatever, I'm only losing 0 volts or 1 volt, whatever it is. And therefore, this is not conducting. Current cannot be Current can no way be going through this if I have 0 volt voltage drop across this. That's why you have to understand the voltage and the current. Is current flowing even though I have a voltage over here? This is what's not being taught. I believe in many schools or other places, they're only taught measure 12 volts, measure 12 volts. Oh, it's good. No, not good. Where is it being connected to? Look where it's connected to. If this is a 0 volts over here, the ground, I have current flowing. Why? It's a complete path for current to flow. If this is connected, the computer board is connected, then I'll have 12 volts here, 0 volts over here, I'm connected to ground. Fine. Then this will toggle. This is the most important point. Go to the schematic and look. Now, is the ignition switch good? Now, let me make the point even more. Stress the point even more. Whether this is working, look at this. If this is connected to the ground, correct? This will be 12 volts. This will be 12 volts. Why? Because it's still connected to the battery. Do I know if this is working? If it's working? Not really, because all I know is 12 volts, 12 volts. Whether this is working with the ground, whether it's working without a ground, will give me the same 12 volts, 12 volts. Why? Because it's always connected to the battery. See? If you go to this fuse, even though you have no current flowing in it, right? Let's say there's no ground. It opened up. Well, if there's no ground, you cannot have current flowing through this one. But you'll always have 12 volts here and 12 volts over here. Why? Because it's still connected to the battery positive. And you'll see that test when I do it. I go across this fuse, I will measure 12 volts here, and I will measure 12 volts here. And I'm not even going to be in the start position. I'm going to be in accessories or lock position, because you know why? I'm still connected to the battery. So you cannot rely on the voltage measurements to always tell you if there's current flowing. That's why you have to come to this critical point over here and make sure you measure 0 volts to ground. That will tell me that current has a complete path. This has been activated. I know it's a difficult point to make and a difficult point to absorb. I know that. But this is the only way that it could be taught correctly. Okay, I know, like I said, everywhere is taught power here, you have power here, power here. First of all, power, this is not power. This is voltage. Power is watts, E times I, voltage times current. This is not power. The unit of measurement for power is watts. This is voltage. Different totally. Anyway, like I said, absorb it, go over it. Any comments like that? He left a comment that did not go over this. Much appreciated. I love comments like that where they delve into the schematics, the viewers. I love comments like that. Thank you for your observation again. I mentioned it before. I'll mention it again. Like I said, for this channel, Automotive Electronic Schematics by Joseph, please go to this channel and go to my other channel, Joe Electronic Schematics for Auto, where it was monetized. Thank you for the support and hope to see you in another video. And please go over this slowly because it is a difficult concept to absorb. But how do I know the ignition switch is good? Well, that's what we started with. You know what? If I have 12 volts over here, when my friend puts it in start, I know there's a connection from here to here. If he starts the car and it's in lock position or whatever, or run, and then I tell him put in start, and I measure 12 volts at the fuse. I go to the fuse to measure it. Am I not making a connection from here to here? I am, right? That's why I have 12 volts here at the fuse. I don't have to go rip out the whole ignition switch underneath the steering wheel. I have a point right here. Why should I do that? Right? It's all about easy access. Why should I do that? And then you have to take off the negative from the battery. You have to wash the airbag that might implode and all that. Why do that when you have a fuse right here that tells me this is the same point as this? And this is the same point as this. There's only a piece of wire over here. So why should I not go to the fuse? This is what I never understand. Trying to understand from channels and all these things. Oh, let me go to the... If I don't measure 0 volts here, and I measure 0 volts over here at the fuse, right? But I measure 12 volts over here at this fuse, then I'll say, okay, maybe the ignition switch. But if I measure 12 volts over here, and I can go to an easy access point over here and another fuse, which is so easy to get to, that tells me I have a connection from here, to the battery. How do I have a connection? Because the start ignition switch is in the correct position. It's making a connection. Okay, so please go over it. Thank you so much.